What does it really mean for an AI to think? Today, we're diving deep into AI Workflow Automation Explained. AI Workflow Automation Explained. In 2026, AI agents have become reliable enough for production environments, but workflow architecture remains the primary determinant of business value. Many organizations deploy advanced models yet still rely on manual coordination between teams, systems, and decision points. The largest gains come from automating end to end processes rather than individual tasks or isolated model interactions. Workflow automation transforms AI from a productivity tool into an operational system. But here's where it gets interesting: the stitch point. Manual coordination is the bottleneck. Traditional automation technologies were designed around predictable paths and structured business processes. Every exception requiring human intervention introduces delays, context switching, and operational overhead. Teams spend more time coordinating systems than executing the work itself. The result is fragile infrastructure that becomes increasingly expensive to maintain as complexity grows. So, what's the real problem? Let's talk about why deterministic fails. Fixed logic cannot adapt to variable AI outputs. Large language models generate outputs based on probability, context, and reasoning rather than deterministic rules. Traditional workflow engines expect predefined branches, exact schemas, and predictable execution paths. As AI capabilities expand, the mismatch between static logic and dynamic reasoning becomes increasingly visible. Successful systems require orchestration layers capable of adapting to uncertainty in real time. This raises a critical question: the orchestration breakthrough. Agents that plan, execute, and revise. Modern agents can interpret goals, select tools, execute actions, and revise plans when outcomes differ from expectations. Improvements in structured output, tool calling, and execution reliability have made production deployment practical. Instead of following predefined sequences, agents dynamically generate workflows based on available information. Persistent workflow state allows decisions and context to survive across multiple reasoning cycles. Now, let's zoom in on system architecture, a five-layer stack for autonomous workflows. Production systems typically begin with a trigger layer that captures events from users, applications, or business systems. The orchestrator coordinates execution while managing dependencies, retries, and workflow state. Memory provides context, persistence, and historical awareness across tasks and sessions. Tool registries expose APIs, databases, and services, while human handoff mechanisms provide governance and escalation. Here's something most people overlook: core components, four primitives that compose any workflow. The planner translates objectives into structured action sequences with clear dependencies and priorities. The executor interacts with external systems while validating inputs and enforcing operational constraints. The validator evaluates results against business goals, policies, and quality requirements. The router determines whether a workflow should continue, retry, escalate, or terminate based on current state. Think about this for a second. Example workflow: ticket resolution. From support request to system update in 12 seconds. A customer request enters the workflow and is automatically classified according to intent and urgency. Relevant knowledge is retrieved and combined with organizational policies to generate a proposed resolution. Validation layers verify compliance, confidence scores, and expected business outcomes before execution. Human intervention occurs only when confidence falls below predefined thresholds or risk levels exceed policy limits. And this is where things get complex. Measurable impact. Process automation yields 10x throughput gains. Validator-driven workflows significantly reduce hallucinations and execution errors before they affect customers. Automated orchestration compresses cycle times from minutes or hours into seconds. Horizontal scalability allows a single orchestrator to manage hundreds of simultaneous workflows efficiently. Organizations gain both operational efficiency and improved service consistency across business functions. But here's where it gets interesting: future trajectory 2026 2027. Multi agent swarms and self improving workflows. Future architectures will distribute responsibilities across specialized agents optimized for specific functions. Planning agents, execution agents, security agents, and validation agents will collaborate within shared workflows. Historical performance data will continuously improve workflow decisions and optimization strategies. Compliance and governance policies will increasingly be enforced directly by orchestration infrastructure. So, what's the real problem? Let's talk about integration patterns. 3 ways to connect AI workflows to reality. API native integrations enable secure interactions with enterprise systems through authenticated tool access. Retrieval augmented workflows inject relevant context dynamically at each stage of execution. Human in the loop patterns allow approvals, escalations, and exception handling without disrupting workflow continuity. The most effective systems combine all 3 patterns depending on operational requirements. This raises a critical question: governance and safety. Control without breaking autonomy. Production workflows require permission controls governing which actions agents can perform and under what conditions. Every planning decision, tool invocation, and generated output should be traceable through audit logs. Safety mechanisms enforce organizational policies before actions reach external systems. Automated rollback capabilities ensure workflows recover gracefully when failures or violations occur. Now, let's zoom in on equilibration roadmap. Start with one high-frequency, low-risk workflow. Begin by identifying repetitive processes that generate measurable operational costs or delays. Convert manual activities into atomic tools that can be orchestrated independently and observed clearly. Define objective success criteria, validation rules, and escalation paths before deployment. Launch with human override enabled, measure outcomes continuously, and expand automation incrementally based on proven results.